Imagine spending your life savings on your dream home, only to have a government inspector slap a bright red tag on your front door. The bold letters read, "Stop work." Your house is declared uninhabitable, all because of a simple plastic pipe sticking out of the mud. This pipe is the intake for what is known as an earth tube system. It is a remarkably simple way to cool your home for absolutely free, using nothing but the ground beneath your feet. But while you see energy independence, the system sees a violation. The concept of an earth tube is beautifully simple. You bury a high-density polyethylene pipe, or HDPE, about 2 meters deep in your yard. In temperate regions, some researchers suggest the soil at this depth maintains a stable temperature between 10 and 15 degrees Celsius all year round. A small, low-wattage fan draws that naturally cooled air from the earth directly into your home. There are no massive electricity bills. There are no loud compressors, just pure, free cooling. But then the building inspector arrives. They look at your trench, shake their heads, and pull out the red stamp. In the eyes of the law, your system is classified as an unaddressed technology. If a system is not explicitly written into the building codes, most inspectors will refuse to approve it. Under the International Residential Code, specifically Section M1601, using the raw earth as a direct duct for breathing air is generally restricted. No local engineer wants to sign their name on the permit, and no inspector wants to take the legal blame. Some off-grid advocates believe corporate interests have successfully pushed for regulations that make DIY earth tubes nearly impossible to license. They argue that safety codes are being weaponized to protect a multi-billion-dollar market. But building inspectors actually have a very real, very terrifying reason to hate this pipe. And it is a danger that could quietly threaten the lives of everyone inside your home. Deep beneath the quiet soil of your backyard lies an invisible, odorless threat. It is called radon-222. This radioactive gas is a natural byproduct of decaying uranium deep within the earth. According to the Environmental Protection Agency, or EPA, radon is the leading cause of lung cancer among non-smokers. The agency estimates it is responsible for roughly 21,000 deaths every single year in the United States alone. You cannot see it, and you cannot smell it. On official maps, entire regions are highlighted in warning red. These are areas where radon concentrations frequently exceed the safe limit of 4 picocuries per liter. Normally, this gas rises through the soil and dissipates harmlessly into the open sky. But when you bury a plastic pipe 2 meters underground, you might be creating a direct highway for this gas to enter your home. Many people assume a brand new PVC or HDPE pipe remains completely airtight forever. But the reality of the underground is brutal. Over time, the immense weight of shifting soil puts constant pressure on every single joint. Microscopic cracks can easily form. Meanwhile, your warm house acts like a giant vacuum. As warm air rises and escapes through your roof, it creates negative pressure on the lower levels. This physical suction forces your home to draw air from any opening it can find. It pulls the toxic radon gas right through those tiny underground cracks and pumps it directly into your living room. Yet, even if you live in an area with absolutely zero radon, this pipe still has a fatal flaw. Without you ever knowing, the tube can start manufacturing its own toxic hazard right inside the dark, buried walls. And this time, the threat is born from nothing but water. But even if you live in an area with absolutely zero radon, this buried pipe poses another hidden danger. It can actually manufacture its own toxin right inside the dark tube. And this time, the culprit is simply water. Imagine a hot, humid summer day. You pull that warm, wet outdoor air into a pipe chilled to just 12 degrees Celsius. What happens when warm, humid air suddenly meets a freezing surface? It hits its dew point instantly. The moisture has nowhere to go. It condenses, forming millions of tiny water droplets that cling to the dark plastic walls. Before long, this water begins to pool at the bottom of the tube. Now you have a dark, damp, and stagnant environment deep underground. Can you guess what loves to grow in a place like this? It is the perfect breeding ground for toxic black mold, known as Stachybotrys chartarum. This mold does not need much to survive. It feeds on the tiny dust particles carried in by the wind. But how do you clean a pipe that is only 15 centimeters wide? Remember, this tube stretches for 30 meters and is buried 2 meters beneath your lawn. You cannot crawl inside to scrub the walls. You cannot run a giant washcloth through a buried, twisting maze. Have you seen those online DIY videos claiming a simple gravel drain will solve the water problem? In the real world, those drains quickly clog with soil, roots, and biological slime. The water remains trapped, stagnant, and rotting. When you turn on your ventilation fan, a silent disaster occurs. You are not drawing in crisp, clean country air. You are blowing millions of microscopic mold spores directly into your living room. Your eco-friendly system has become a toxic underground lung, breathing poison into your home. But let us say you find a way to kill the mold. What if you install expensive ultraviolet sanitizers to keep the air clean? Even then, this buried pipe poses an even greater threat. It can quietly destroy the single most expensive asset you own, the very foundation of your house. Even if you manage to filter out every single mold spore, a deeper danger remains. This simple plastic tube can still ruin the most expensive thing you own, the very foundation of your house. If you dig a deep trench too close to your home, you risk triggering a structural nightmare. When you excavate 2 meters down, you remove the lateral support of the soil holding up your house. Engineers warn that violating the natural angle of repose can cause the earth beneath your foundation to slide. The concrete cracks, the walls buckle. Suddenly, a project meant to save you money ends up destroying your home. This is why building inspectors are so incredibly strict. In many ways, their refusal to approve these systems is rooted in genuine safety. But this is also where the story takes a darker turn. The multi-billion-dollar modern air conditioning industry did not create these physical laws, but they certainly know how to use them to their advantage. By highlighting these real, terrifying risks, some off-grid advocates believe corporate interests have successfully pushed for regulations that make DIY earth tubes nearly impossible to license. They argue that safety codes are being weaponized to protect a massive market share. After all, a cooling system that lasts a lifetime is a nightmare for any corporate finance department. They want you trapped in a cycle of buying, repairing, and replacing their complex machines forever. But what if you could bypass their entire trap? How do you harvest the Earth's perfect temperature and bring it indoors safely? How do you do it with zero radon, zero condensation, and with a system that building inspectors are highly likely to approve? It is not only possible, it is surprisingly simple. The solution lies in changing the way we move the heat. Instead of pulling raw air through a giant buried pipe, we can move a safe liquid through a tiny sealed loop. This is the closed-loop glycol system. For many off-grid builders, this is the ultimate loophole. By using this method, you can bypass the three biggest roadblocks of traditional earth tubes: no radon, no mold, and no foundation damage. First, you bury small diameter pipes under your yard. These are thin, flexible tubes made of high-density poly-HDPE. Typically, they are only about 25 millimeters wide. Inside these sealed pipes, you run a mixture of water and food-grade propylene glycol. This is a non-toxic, safe antifreeze. Even if a minor leak ever occurs, it is generally considered safe for your soil and groundwater. A tiny circulation pump pushes this liquid through the loop. This pump is incredibly efficient, often using only 15 to 45 watts of electricity. As the liquid travels deep underground, it absorbs the Earth's natural temperature. In temperate regions, this ground temperature stays remarkably stable. The chilled liquid then flows back up into your home. Here, it enters a hydronic heat exchanger coil installed inside your indoor air duct. When your home's air passes over this cold coil, it cools down. But what about the condensation? Any moisture in the air condenses right there on the metal surface inside your house. It drips safely into an accessible tray that you can easily slide out and wipe clean. Because the underground loop is completely sealed, radon cannot find a way in. Because the condensation happens indoors, mold has no dark underground tunnel to thrive in. And because these pipes are so small, you can bury them far away from your foundation. This is why building inspectors are far more open to this setup. Under standard codes, it is often treated just like hydronic radiant heating. It is safe, proven, and highly compliant with modern building regulations. But to make this system actually work, you cannot just throw pipes in the dirt. You need the exact engineering specifications. These are the kinds of calculations that professionals charge thousands of dollars to design, and I am going to give them to you right now, completely free. Here is the blueprint to help you get started. As a general baseline, to target around 1.2 kilowatts of cooling capacity, a typical setup might use 60 to 80 meters of 25 millimeter HDPE or PERT pipe. For maximum stability in temperate regions, this loop should ideally be buried at a depth of 1.8 to 2.2 meters. At this level, the Earth acts as your personal thermal battery, completely shielded from the scorching summer air. Inside the pipe, you will want a mixture of 25% food-grade propylene glycol and 75% distilled water. This specific ratio helps prevent freezing while keeping the heat transfer highly efficient. To move this liquid, a small 3-speed circulation pump is all you need. It draws a mere 15 to 45 watts of power, which is less than a single traditional light bulb. This pump connects your ground loop directly to a hydronic coil, placed right at the fresh air intake of your home ventilation system. With this setup, you can watch your electricity meter virtually grind to a halt. you have successfully tapped into the free, unlimited energy of the earth. But cooling your home is only one half of the equation. When winter comes, how do you keep 90% of your indoor heat while constantly bringing in fresh air? And how do you do it without spending a single extra cent on your heating bill? The secret lies in a home-built heat recovery ventilator made from simple, salvaged materials. I will show you exactly how to build one in this next video. Quick heads up, this video is for educational purposes and sharing technical concepts. Always check your local building codes and consult a professional engineer before doing any heavy digging.